Hi, I'm Srikanth. I'm co-founder and CEO of Fractal. I have the real privilege of hosting Dr. Lee Deng, Chief AI Scientist of Microsoft today. Hi, Lee. Good to meet you.
Good to meet you. It's a great pleasure to be here.
Great. Lee, you're one of the foremost thinkers in the areas of deep learning and AI. At Microsoft, you're pushing the agenda really forward. And over the last few years, you've written some of the most well-known papers in the deep learning space, especially in the speech processing area, worked along with people such as Geoffrey Hinton and so on. I just want to understand what started it all.Here did you start?
Yes, I actually originally came from academic. I was a professor at University of Waterloo many years ago. And during that time, I already started looking into some of the neural network applications and also algorithm there. That was in mid-90s. At that time, just like everybody else working in the neural network area, since the data wasn't big enough and computing power wasn't big enough, and many people struggled to make it work, including myself, including Geoff Hinton, including many other very well-known scientists in neural network. It's very difficult to make a very large-scale computation and taking advantage of extremely large amount of data. Since in my particular area of speech recognition, the data have been accumulated over years, 20-some years, mostly funded by U.S. government, actually, DARPA. When we participated in competition, government actually provided a very large amount of training data every single year. So in that sense, up until about 10-some years ago, the availability of data is there. And also around that time, computing power got dramatically increased due to the availability of GPUs. And these things coming together, and I think speech is really sweet spot because these two conditions are there. And then people realize, such as myself and Professor Geoff Hinton and some other deep learning researchers, we all realized that, wow, the time is there. That was about 8 to 10 years ago. So at that time, I had been moved from university to Microsoft for quite some time. And we realized that now for industrial application, we need to have very massive scale of computation, which now can be afforded with the availability of data computation. And now the only missing piece is the algorithm. What's the best algorithm to do it? So I actually invited Professor Geoff Hinton to come to Microsoft Research in Redmond, Washington, to sort of brainstorm how this deep architecture, either in terms of generation model or in terms of neural network, could actually fundamentally change the landscape of speech recognition and down the road, maybe for other applications as well. So he actually got my invitation, and then we actually worked together. And then after the exploration, we really realized that having the new algorithms with the deep architectures, it can actually dramatically increase the capacity of the model compared with the previous technology based upon probabilistic modeling. Once we actually have massive amount of training data, many of these tricks that academic originally proposed may not be needed any further. It just apply very straightforward algorithm called backpropagation, and with some novel architecture that also takes into account the temporal properties of speech in combination with neural network, really can drastically reduce the error down. And since then, that happened around 2009, 2010. That actually can be considered the very first success of deep learning in industrial scale. And since then, the whole computer vision community get awakened, realize that, wow, this technology, having very deep neural network, can really change the way that computer vision is done, just like it changes speech recognition is done. And then, the whole industrial scale of AI based upon deep learning simply took off.
Great. One thing, just to summarize, one of the things you said is that there is certainly much more data, much bigger compute, and some modifications in the algorithm together have created this magic out of nothing.
So actually more than just modification algorithm, it's actually the architecture design is playing a very important role.
Got it. Uh, there have been many other such revolutions in AI. If you look at the 60s and the 70s and 80s, we've had waves of where people got very excited with the progress of AI, and then all of them had very disappointing ends to them. And so we had these really long AI winter, and now people say it's the AI spring. So my question to you, two questions. One is this AI spring going to turn into AI summer, or are we going to land into some kind of a plateau where we stop making progress?
I do believe that this new wave of AI, based upon deep learning success, is going to last much longer than the previous ones. How long it is very hard to say. I mean, it all depends on many factors, and that's one of the reasons why having a lot of researchers and the engineers going into this field is a very good thing, because now we are conquering, AI task one by one, starting with speech and then image. Now, from what we have seen, from published result, machine translation area is part of natural language processing. Also, is making huge impact. Actually, the result actually already came out last year to show that the deep neural network approach, with a very elegantly designed what's called the sequence learning with attention that simulates humans' attention mechanism, in a very crude way, already can do better than the statistical approach, just like speech, the statistical approach, probabilistic approach that I mentioned earlier. And natural language understanding, and reading comprehension, and now also dialogue system, for example, with the bots. And the algorithm research is really active. And I do believe that this line of research is going to push this wave of AI to be much more, I wouldn't call it summer, right? Summer to me is very hot. Sometimes it's going down, right? I don't think we are even in that summer yet. I mean, we're still in a very, very high, very fast, very steep slope at a global level. Not only U.S. but also in China.
In fact, people are scared of AI too. I mean, given the number of applications, you talked about chatbots, and people are scared that will change the, let's say, the call center industry completely, or the outsourced service industry completely. And AI might replace tons of jobs as machines take a larger share of human decision making. Yeah. In this world, do you see this world going that way and humans being irrelevant? And if so, what should we do?
No, actually, I think for the AI researchers, we sort of embrace the concept of symbiosis between human and AI. Right? So human design AI system. Right? So many media discussion about AI, consciousness, and these are very far away. Right? But on the shorter term, it is what you say is actually indeed true, that AI will replace many human labor. The most obvious example is driverless car. Right? Yeah. It's actually imminent, and I heard some lawyers even talking about how to institute some laws now, so that when the technology become available, when the driver car is around, a few years down the road, we already have legal system in place, and so this is very imminent. It is true that drivers probably may not actually need to drive as much as they do now, and then of course that part of section of the job will be replaced. Maybe not 100%, but certain percentage.
So probably learning to drive or being a driver as a profession may not be a good idea anymore, given what we are expecting to see in this world. How does a 10-year-old in this world, what should a 10-year-old focus on learning, given that number of different kinds of jobs, especially the ordinary jobs, are going to go away? That's a scary situation for most common people.
Yes.
And if I have a 10-year-old child, what should I focus on learning at this point of time from the point of view of this child?
Yeah, from what we discussed earlier. So any job that can be easily replaced by AI agents, by computers, that may not be the right area to go, right? But most of human activities, such as creativity, such as science, such as engineering, that require human skill and requires that human in collaboration with the machines to solve the problem. All these areas ought to be, extremely fruitful direction for a 10-year-old child to aim. Like medicine, if you are doing detailed medical analysis, just maybe not radiologists, right? If they actually only focusing on the part that can diagnose whether there's a disease or not, and that part job may be replaced by machine. But how to sort of have a holistic way of understanding human body, to understand disease, and these scientific areas will be long way for AI to get, maybe not even possible without the human incorporation with machines.
In the world of data science that we belong to, is it okay for someone to study and become a data scientist now, given that even though AI is going to explode, the number of data scientists required to solve the problems might actually not increase that much? So is it a good idea for someone to be a data scientist today?
Yes, correct. Data science is a very important one, because one of the primary requirements for AI is to be able to actually get the data ready, to go into machine, right? And then how to interface the two. I mean, it's one of the main jobs of data scientist. The data science job is very scientific, right? That's why it's called a scientist, right? There's a scientific way of understanding the domain, understanding the data, understanding how to sort of fit the data into the AI system so that the insight can come out. And all this kind of work are scientific. It requires creativity. I personally believe that a data science job is a fantastic career to go.
Got it. Let's switch back a little bit into the tracks around various kinds of AI. Deep learning, the place that you have specialized most, is sort of now replacing, or at least taking a very large share of AI techniques overall. What about the people who have been working on computer vision for all these years without using deep learning? What should they do? What about the other fields of AI? Should we just stop working on those? Is it all going to be deep learning, or is there a merit in actually combining these disciplines?
Yes, I do believe that the ultimate success of AI requires a very nice combination of the power of deep learning that we discussed so far with other areas of AI in order to achieve the ultimate goal of AI. For example, many people realize already, now including myself, including many, if you read in all the deep learning experts, there is some limitations of the current way of doing deep learning. Number one limitation is that it requires very large amount of matched training data between input and output, and that's called deep supervised learning. That is very successful in speech, in image, and in translation as well. Now, to solve more challenging problem like medical image, so the problem that I have seen over yesterday from your company, and that's small data problem, right? And how to solve small data problem, it requires, number one, neural net can do really good job. It requires much more elegant design, more algorithm need to be there compared with when you have very large amount of data, much more straightforward way can be applied to achieve that. But not only that, also other ways of doing AI, like probabilistic model and statistic model that I mentioned earlier, which I have been doing over, before I started, looking into deep learning about 8 or 9 years ago. They actually will become very important tool to incorporate world knowledge into the AI system. And neural network has this limitation of some people call it black box. Right? It's not as easy compared to other approaches to incorporate the domain knowledge, which I personally believe to be quite important when you are dealing with specific area of AI application. And of course, there are some other areas of AI beyond neural network, beyond probabilistic modeling and reasoning. Namely, sometimes people call it symbolic rule-based system, and that area of the old AI. This is a very old AI, like rule-based system. In old days, that was very popular in 60s and 70s. That was way beyond when I was doing this. So when I was getting into speech recognition at that time, for those areas of AI, there could be some opportunity to be reborn once they actually realize that some learning system can be now is available. And that area of AI based upon rule system, actually it's very efficient in terms of reasoning if the problem is simple enough. And how to scale them up in such a way that is going to make AI system more transparent is a very important research topic. I think part of deep learning technology will have role in play to make the old fashion of AI to be scalable, and also to be transparent by its very nature, and also to make that automatically learnable. So in combination, deep learning technique together with the old-fashioned of AI that has its own advantage, namely much easier to incorporate domain knowledge in the system, and plus probabilistic listening, all different areas of AI in combination. Probably at the end they should be centered around the deep learning paradigm because it's very scalable.
Got it.
And will actually eventually conquer all the difficult problems in AI.
You touched upon areas where deep learning is most successful today, which is the areas of supervised learning. There are also deep unsupervised learning where I think there is some progress being made, but there's a lot of work to be done. There's reinforcement learning where we've seen some huge successes in the recent past with AlphaGo and others, but there's still work to be done. And from my understanding, even today, deep learning is still not really good at very high dimensionality problems, which are exponentially hard to compute, or areas where there are very small amounts of data, or places where we have to understand natural language. Yes, we've made progress in natural language processing, but not really in natural language understanding. So the machines still don't understand what's really going on. So summarizing a form of text is hard. So some of these really difficult problems, what's your perspective? I mean, is deep learning itself going to provide us these breakthroughs in the next few years? Do we need other branches of AI to come in and help us? What exactly is happening at the cutting edge of research today?
Yeah, as I said, straightforward neural network-based deep learning so far is extremely good for supervised learning. Right? Everybody have seen that. Now for other area applications, the one you just mentioned there, will need, in fact, that's my personal opinion, will requires that different areas of AI will come into together in synchrony with deep learning. And also, some of the problems will require humans' participation, human interaction, because it requires the feedback loop in order to make the ultimate AI system work. For example, reinforcement learning area. Really, the whole paradigm of reinforcement learning is that there is a sort of automatic interactions with the environment and the agent, AI agent. They have to interact. From that, you get learning signal, rather than having to have human to provide exactly what signal it is. And that human in the loop is an extremely important concept in some areas of deep learning and AI area, such as reinforcement learning. Now, for unsupervised learning, and the story is a bit different because you don't even have the label. And how are you going to make use of the data in order to help to do prediction, to do action prediction, etc. Action recommendation. All these areas do require much more in-depth research in order to make AI to become powerful, much more powerful compared to the one we have now. For example, in unsupervised learning, my actual view is that we need to integrate as many knowledge sources as possible. It requires that the AI system to understand the input data, the structure of the data. That's actually one of the earlier unsupervised learning sort of challenge. And once you have this, basically you need to model the world so that you can remove the need for the labels.
Sure.
And also another area in unsupervised learning is that you need to understand the structure of even the output world, not just input world, the structure. For example, if you have to do anything related to natural language, exactly the probabilistic structure, the statistical properties of the language itself. Sometimes people call language model. I think much more important language modeling will be required. So you can characterize the sequential properties, statistical properties of language model in order to help you to do prediction without the paired input-output data in the training, and that's part of unsupervised learning. And of course, other sources of information will include, the relationship between input and output. That's how generative model become useful for unsupervised learning. And finally, for the transfer learning will be extremely useful. You don't have the data for your domain, medical domain that I saw yesterday, but you have domain. You have the kind of knowledge gained from another domain, maybe in voice domain. Right? Then how can those knowledge sources can be transferred from one domain to another? And that's yet another important knowledge source that can help to solve unsupervised learning problem.
Got it. Let's talk a little bit about AI applications. And you've talked about speech processing, where you have done some amazing amount of work in the last few years. and we've seen the error rates drop to a level where it's become feasible to use it for industrial strength applications. And similarly, I think that's what's happened with image in the last few years, and image processing. And I think now that technology has reached a scale where it can be put for industrial applications. Which are the other areas you feel are the next frontiers where deep learning will become part of our life as we see it every day?
Yes, I think natural language processing is the most important area that's kind of crown jewel of AI. So human, is equipped with the language capability that other animals don't have. And that area, so far, there are a lot of progress to be made. As I mentioned, machine translation now is heavily, very strongly impacted by deep learning. But if you really go down into exactly how they do it, it really doesn't require any understanding. It's sort of matching from input output.
Yeah.
And the reason why that happens is because it's black box. The power comes from the label. If you put enough input output data and then via intelligent design, I wouldn't call it intelligent, via very elegant design, neural mapping architecture, including the use of human sort of attention mechanism, memory, mechanism into the model, you actually can do a really good job of matching from one to another. But if you really want to ask what the system understand much, actually the answer is no, it doesn't really understand. In order for human to understand, a pair of text, once you read the text, you understand, you can do other things. Right? For example, not only you can do prediction, what kind of translation you have, what kind of answer you can ask, but also you can recommend things. It can just do multiple things if you really have understanding. Now, the current AI system for natural language processing doesn't have this kind of understanding. So on the surface, you might see that you put English sentence, French come out, Chinese come out, Indian come out. In many of those cases, you get very good quality of this, but it's far away from how it's the understanding of the text, which will allow you to do many other tasks as a human do. Right? And that area, I think, will have a huge potential, very, very huge potential. And unsupervised learning, and also including reinforced learning, will have an important role to play in natural language understanding part. So my own research team also have done quite a number of pieces of work, and we have submitted some really good papers.
So many companies are beginning to think about AI, and it's become very fashionable. There's a lot of media and attention around AI, and big companies are really struggling to figure out how to use AI in their own world. Is there something that they should do? Should they hire people? Should they rely on companies which have deep learning capabilities? It seems like a place where the next big frontier of technology, and companies that are not really tech companies, how should they do it? Should they hire people? It's become really hard to hire people.
Yeah, but it's very hard for me to say about this. Right? But in general, I personally would think that, this is my own opinion, that many small companies do have your assets because you have data. Right? I think data is one of the most important resources for AI to excel. Now, in terms of technology, I think all the big companies have open source a lot of their tools. Microsoft, we did that, and Google open source their tools. Facebook also, Baidu. I think all the major companies, Amazon also, they open source their tools, and those tools are very powerful. And I will hopefully encourage you to use Microsoft a little bit more on this. Now the key is that for different applications, the data really. Let me quote some other AI scientists analogy. So the data is more like fuel, like Andrew Ng, for example, he used that. I really like that analogy. It's like fuel, and the AI technology is like engine. So now deep learning can make engine really big, very big, and then now you get a lot of fuels. If you put them together, that's how the AI application became successful. So now for small companies, for example, you got a really important for domain.
Right. So let's say we curate. Let's say one of the things you're saying is data is a big asset for these companies. This is their competitive differentiator. I think companies realize that they're putting those data together. Still, it's sometimes messy, but I think people do recognize the value of data. Yeah. But I think they're struggling to process this and make meaning out of that. And especially even the traditional analytics techniques, I think people are struggling. As far as AI is concerned, talent is really scarce. And,
Yes.
And what we have seen in the last few years is some of the most leading thinkers in this space who have been at universities have all been sucked into big corporations. In that world where talent is really scarce, how should companies approach this? And second question to you is, how does this change the future of research in this industry? Is research going to suffer because most of the well-known researchers have actually now become part of companies?
Well, but not all, right? A lot of actually good people like Jeff Hinton, like Yann LeCun, like Andrew Ng, they all went from university to. But we still have some very good people like Yashua Benjo's team in Canada. I mean, he's very devoted to training next generation of AI research. I'm very admirable. About a few days ago, there was an announcement that Microsoft, Facebook, IBM, and Google, DeepMind, they have this committee to guard AI safety.
Oh, yeah.
And that kind of, it's very good. I mean, so that's a very good sign that the whole AI world is going to be, at the end, to be more cooperative than competition. Right? And that's a good thing to have. Right?
Right. So you talked about, people have talked about the AI kill switch, and people have this fear that AI will take over this world, and suddenly we create a Frankenstein that we cannot control. Is that fear genuine? Is there real chance of that happening? How should somebody think about that?
Yeah, it's very hard for me to say much about this. As a scientist and as an engineer who actually work on AI technology, on daily basis, and that fear, I personally don't see that directly, at least for many years, down the road. Right? Now we are struggling, very hard to make AI, the whole field move towards solving some of the problems you just mentioned, how to understand the text, how to, make AI system to be able to read the whole book, and then can do lots of things based upon understanding, rather than, human actually reading book is not fast, right? AI can read too fast. To make that understand the whole world, understand the text, so that it can do many useful things for humanity.
So you talked about education. What is the future of education in the world of AI? And secondly, if I want to be an AI scientist today, what should I be learning? What are the elements of becoming a great AI scientist?
So mathematics is very important. Probability is very important because the whole world is uncertain. The current neural network doesn't really put probability into that. It's going to come. Uncertain neural network. You are able to model the uncertainty in the world, and that part of the knowledge is extremely important for for students to learn. And of course, programming is extremely important. You need to know exactly how computer is running. Well, although in the future, maybe many of the programming jobs may be somehow, I wouldn't say replaced. And this is actually another big area: how to use artificial intelligence to the automatic programming. People do that.
Exactly.
But if you don't know how to program, you don't even know how to solve the problem you're dealing with. Right? So I think that's part important. You need to have the programming skill to be able to do AI, and eventually that part will be automated.
You mentioned math, and you mentioned probability, and closely associated disciplines are statistics and economics.
Yeah, that's correct.
Is there any point in being a statistician today?
Yes, very much so. Statistics is mathematics. So I want to say learning uncertainty in the world. I mean statistics, it's the same thing. Probabilistic view of the world, statistical technique that enables.
What about classical statistics? I mean, there are the whole area of classical statistics. Deep learning has turned it on its head.
Yes.
I understand the understanding of probability is important, but whole range of classical statistical techniques, do they still have relevance in this world?
Yeah, I do think so. I mean, for example, how do you test, whether our AI system can do well or otherwise? Like many application scenarios in your company's application. Yesterday I heard this kind of a trial. It's a demo that you show me. Trial run. I mean, that's all statistical problem. So if you, even after you use the AI to automate that process, you have to evaluate exactly how it do, and then all the statistical technique will come into form.
How do you groom people? And we've discussed in the past also, hiring people is really hard. So how do you look for that talent, and how do you groom that talent today?
Yes, I think the best way to to develop talents is to do hands-on the project together. So in my team, I have I have quite a number of very, very strong people. After you get PhD, right? After you get PhD, you get the basics all covered. You understand, exactly how, mathematics works, how programming works, how the AI system general work, and the best way actually, into real project to solve problem of speech, image, natural language processing, and some recently maybe some of the business problem that I heard from your company. And those hands-on results, and also very important to know how to read scientific papers. Right? And now in this area, we're very lucky. Right? There's, everything's open source. Right? Like even publication is open source, like arXiv. Right? So most of it, I myself actually read a lot of arXiv papers.
Do you get inspiration from other disciplines?
Yeah, I do enjoy reading a wide variety of scientific field, like neuroscience, anything that has sort of breakthrough findings, about how certain part of the brain actually works, especially in auditory system, about perception. I keep very good track of their progress. And I read scientific papers that published in Science and Nature, mostly related to how the brain functions. Some scientific discovery. I read a lot of those.
Right.
And
do
also
you feel that how the brain really works? I mean, we still have very little understanding of how brain really works. What are the biochemical phenomena that actually create memory and intelligence and sleep? And we still are struggling to understand some basics of the functioning of the brain.
Yeah.
Do you think learnings from there will directly impact how we do deep learning?
Yeah, I do. And I do find that many of the, the principles that underline brain's function, not just in terms of neural level, but in terms of neural assembly level, in terms of system level, in terms of the columns in the brain, their functional roles. Those are very inspirational in designing the next generation of neural network architecture, in order to actually move towards the capability that brain will have. But we are far away from that. We still don't understand in the global scheme about how human intelligence actually is grounded on.
You spoke about how knowing how the brain works might help us in understanding and improving deep learning. But do you think the other way around is also possible, that we learn from deep learning and apply that to understand how the human brain works?
Yes. Yes. The answer is yes. One example is I just mentioned about how the the dropout mechanism help to informing us that the spiking neuron will have important role to play. Right? And the other example is more in terms of techniques, like for image analysis, image segmentation techniques that was developed in deep learning technology. Now it become one of the most important instrumental tools to help connectomics, human connectome project.
Got it.
And that's one very prominent example of how neuroscience benefit from deep learning technology.
You recently won the Outstanding Contribution Award for IEEE. Can you talk a little bit about that?
Oh yeah, thank you very much. Yeah, so that I think so this is first of all this is really acknowledgement by by the teamwork. So I was the one who actually started a bit earlier, and then I do have a good team working together. So that actually I appreciate IEEE very much for giving this award to me, to recognize the earlier work, the pioneering work about applying deep learning into speech recognition. So that was what I told you about 2009, 2010, when we first identify that the deep architecture of neural network can be extremely powerful for large-scale speech recognition. And I'm very so glad that now this way of doing the work now is taking off by the whole world. So that's I appreciate. I also appreciate all the teamwork that we have had.
It's been a fascinating conversation, Lee. Thank you very much for spending quality time with us and talking about the leading and bleeding edge of deep learning and the future of AI for this world. Thank you.
Thank you very much, Rikan. I really appreciate having the opportunity to discuss.